So, when we get into quadratic inequalities, basically we're going to combine graphing parabolas with shading with interval notation. So it kind of puts it all together. So it's a nice review, but hopefully it's something that if you've missed out on something before, it gives you a chance to see it again. Okay, so when we're graphing quadratics, a few things to pay attention to. One, should the function's boundary, now that's a really fancy way of saying something simple. The function's boundary is basically just a fancy mathematical way of saying, should the parabola itself be solid or dashed? So we're going to actually have to take into consideration now when we connect the dots with our parabola, is it going to be a solid line or a dash? You're like, how am I going to know this? Actually, it's fairly simple. If the arrow has an or equals to, has a line underneath, it's going to be solid. If the arrow that you're working with doesn't have a line underneath, it's going to be dashed or dotted. And that's how we explain to somebody if those particular values are included in my answer or not. Okay, except we're doing it graphically. Okay, how do we graph that particular function? We'll get to that. And then where do we shade? Because there's actually, some of you like to color, you get to color with this. Where do we shade, inside the curve or outside? And what we're going to do to figure that out is we're going to test a point inside the parabola. And I'll talk about that once we do it on this first one. I'm going to test a point, and once I've tested it, if that point comes out true, we're going to shade inside. If it's false, we're going to shade outside. And I'll give you a minute to write that down. And like I said, for right now, it may not make a lot of sense because you're like, what are you talking about? True and false? I don't see like a true-false question anywhere. We'll get to that, but it's just kind of the process that we're running. So like I said, we're going to graph parabolas. We're going to talk about the vertex. We're going to go back and talk about intercepts. So it kind of gives us a second chance to get hold of some things. So when we graph these, do I have an option to just plug it in the calculator? Sure. If I don't have a calculator, can I do this? Sure. So here's what I'm going to do. Typically, when we're trying to find the vertex of something, we have a couple of options depending on what the form is. Notice with these, I don't have a b value. I don't have something that just says x. So for me trying to do negative b over 2a, I'm basically going to get the same answer every time. Because if I took this and I attempted to find my vertex by doing x equals negative b over 2a, if there's no x, what's my b going to be every time? 0, okay. So if my b is 0, that means my x value is going to be 0. So here's what I want you to do. And I'm going to make a big note of this here. If there is no x term, and there's not in number 1, number 2, or number 3, the x value of my vertex is going to equal 0. No exceptions. Yes, sir? But for right now, we're doing this anyway. So, again, we're working on this right now. Yeah, playing from behind constantly, not going to help. Need to focus in on this right now. So, since I know my x value is going to be 0, and my vertex always goes in the middle, I've got that. So you're like, well, how do I find y? Just like always, we're just going to plug it in. What's 0 squared? 0. Now, at this point, I have a choice. If I have the graphing calculator, I could go ahead and plug this in. Now, if I don't, it's still not impossible if I plug in a couple of values greater than 0 and a couple of values that are less. Because all I'm going to do now is say, okay, plug in the 2 for x. 2 squared is 4. Okay. 1 squared is 1. Okay. Oh yeah, when I'm doing a parabola, it's symmetrical, which means these two values should match up with these guys. But I'll make sure. If I put -1 in parentheses and square it, negative times negative would be positive 1. And -2 squared, negative times negative. Okay. But like I said, if you get one sometime where you're not completely comfortable, you always have the option of going to your y equals. Okay, I know it's got a arrow in here, but we'll treat it the same way. Just typing in x squared and going to a chart, especially if I know what the vertex is already. And I knew what the vertex was. It was 0, 0. And I look and I'm like, hey, check that out. 1 and 1, 4 and 4. 1 and 1, 4 and 4. Cool. So I go ahead and I get those points plotted. And if I happen to see some extra points that are available on the chart, I'm just going to go ahead and use them. So I'm going to use the 3, 9 and the -3, 9. But don't connect your dots quite yet, because, again, this is one of our questions with these. Actually, it's the first question. Should our function's boundary be solid or dashed? Line under my arrow, so which is it going to be? Solid. So I am just going to literally connect all the dots this time. Go ahead, put my parabola in. So now, here's the new part with this. We did number 2, we graphed it. Where do we shade, inside or outside? Here comes this test point that I was talking about. We want to pick any point, doesn't matter where, as long as it's inside the parabola. So like, let's say for instance, I'm like, okay, I pick this point. And again, it's just random. It doesn't matter. Any point in here would be okay, but I'm just going to use this one. So I'm going to test out, let's see, at 0, 4. As long as it's inside, we're good. So, okay, what does that mean? That means I'm going to plug in 0 for x and 4 for y and see if the statement is true. So let's see, if y is 4 and x is 0, is 4 less than or equal to 0? No. That is false. So if the answer is false, I'm going to shade outside of my parabola. That's where my solutions are. That's where this statement is going to be true, outside of my parabola. If it would have been true, I'd have shaded inside the parabola. And that's basically what we've got working on these. Yes, sir?
Why did you pick 0, 4?
Any point inside of here I can use. Because by testing one point in there, I'm basically testing all of the points in there. So yeah, if you'd have picked like 1, 8, you'd have got, it'll work for you too. So now, just reminding myself, if there's no x, the x value of my vertex is going to be 0. I'm like, okay. Since there's that +4 on the end, my vertex is going to be at 0, 4, because it would take my 0 and it'd shift it up 4. Or I could plug 0 in and see what comes out for y. It would work the same way. Now again, this is just me. 2 values above, 2 values under. And for me personally, I think this is easy enough. I don't really want to bother putting it in the calculator because I can do this in my head faster than putting it in there. 2 squared is 4, plus 4 is 8. Okay. 1 squared is 1, plus 4 is 5. And I know this is going to be symmetrical, so I'm going to go ahead and stick those same values above. Once I've got my table ready, I'm going to go ahead, I'm going to make my dots, but again, before you go drawing the line, think about it for a minute. So I've got my table, got my dots. What type of line is going through the dots this time? Dashed or dotted, because there's no for equal to. And again, that's my way of signifying that it's just greater than. It's not greater than or equal to. So once I do that, again, pick any point inside the parabola. Now, I always like using something on an axis because it lets me play with 0, which is easy. So like here, let's say I pick, I don't know, 0, 8. Anywhere inside. So if I test 0, 8 out, again, this is my y, so I'd have 8 is greater than 0 squared plus 4. Is 8 greater than 4?
Yeah.
Yes. That's true. And if it's true, I'm going to shade inside my parabola.
Wait, why did you get 8?
This or here.
Okay, but I picked 0, 4.
Wait, you picked 0, 4?
Yeah,
Okay, but wait a minute. Okay, but 0, 4 is on your parabola. It's got to be inside of it. If you pick a point that's on your parabola, you're going to run into a problem because you're going to get a statement that could play either way. It's got to be fully inside. Can't be outside, can't be on. So I just want to make sure I pick a point that's not too close in case I got a little sketchy with my graphing. Well, it'd still just be 0. So like, yeah, on this next one, I look and I'm like, okay, still no x term. So let me shift over a little bit here. Bless you. So I'm going to be at 0. Even though that negative's there, my vertex still is getting shifted up 2. Okay, so it's just 0, 2. So you're like, dang, it seems like I get to keep using these same numbers. This is kind of nice. It's nice when there's not an x value. That'll change, though. So once I get that, again, now be careful here. That negative is the equivalent of being outside your parentheses. So like if I were plugging this into a calculator, here's what it would look like if I was doing it manually. Like let's say I was doing 2. It would be negative 2 squared plus 2. Notice the negative being on the outside is going to change my answer. Because 2 squared is 4, but then the negative gets added. So that's the difference when I see the negative out here. It's different than when I'm plugging it in. So in this case, that's going to be negative 2. And it would be the same thing when I do negative 1. The negative's outside if it's part of my equation, and it is here. And again, the nice thing is, once I get these 2 done, I got the other 2 ready to go, as long as I trust that I'm doing my math correctly. Now, if I wasn't sure on one of these, like maybe the negative spooks me out a little bit, if I've got some in-class time, like we're going to have a little today, we're going to have some tomorrow too, maybe I put it in here and I go to the chart to make sure that I did it right. I'm like, oh, okay. 1, negative 1, okay, that's just like the chart, and the 2 and the negative 2. Okay, I feel better. Looks like it's opening down, so as long as this opens down, I feel pretty good about that too. Get my dots in. The more the merrier. You know the next question that's coming though. What type of line's going through my parabola this time? Dashed. Okay. And this is why we always make sure, because we may not draw a perfect parabola, that's why we always want to stay towards the middle with our test point to make sure nothing bad happens here. Let's see. Somebody throw a test point at me. 0, negative 2. Okay. So let's see. My y value, that'd be negative 2, is less than negative 0 squared. That's kind of funny to think about. Plus 2. So is negative 2, 0 squared still 0, is negative 2 less than 2? Yes. And again, since that's true, I shade inside the parabola. That's where my solution set's going to be. Okay? Any issues so far? Because again, the vertex idea is going to change a little depending on what the graph looks like, depending on what my equation here is. But again, we haven't had an x term yet. So that's made it a little bit easier on our vertex here. You're like, no, just a few things to get used to. Okay. So then what happens if there is an x value? Okay. When there's an x value, let me separate this off here. Oh, some of you, you're going to be ready. Here comes the Algebra 2 F word. When there is an x value, factor and find the intercepts. Now, could I keep finding a vertex? Yes. But it's not going to end up helping me down the road. So here's how this is going to work. When we're trying to factor something, we always look first, of course, with the golden rule, to see if they have anything in common. Do those two terms have anything in common? An x. Okay, so if I get an x, what does that leave me with to put inside my parentheses? X and negative 4. Okay. You're like, okay, well, so now what? Well, when we're finding intercepts, we're just going to set each of those equal to 0. Okay, even the x? Yes, even the x. So I'm going to have intercepts at x equals 0. And then if I set x minus 4 equal to 0, those are going to be my intercepts at 0 and 4. And hopefully this has given you a little bit of a flashback to when we did this at the beginning of this unit. Oh yeah, when you use the intercepts, you find the vertex by finding kind of the midpoint of this. So remember, I can find that value one of two ways. When I want my vertex, I can either take my intercepts, add them up and divide by 2. Remember, don't forget the parentheses. So 4 divided by 2 would be 2. That would be my x value. If some of you like being more interactive, just start from the outside and start counting in until your utensils come together. They came together at 2. But then to find my y, I just plug it into this part. So my y would be my x value squared minus 4 times 2. I'm just replacing the x with its value. So 4 minus 8 is negative 4. So my vertex is at 2, negative 4. There's my third point, and that's enough for me to make a graph. So that's kind of nice, actually, because now instead of having to have like 5 points or something, 3 is good enough. What type of line am I going to use to connect the dots? Okay, line underneath is going to be solid. Now remember, it's a parabola, so get a little curve going here. And again, when you're picking your test point, don't pick something that's right next to your parabola. Find something toward the middle. So like, what would be a good example here of a good test point?
2, 4.
Okay, 2, 4, 2, 0, any of those. Anything that is far away, far away from the middle. So if you want to test a different one, you can, because we should both be getting the same solution here. So 2, 4. So if I test that out, okay, so my y value is 4. My x value, and again I put it in parentheses, is going to be 2. All right, let's see what happens here. 4. 2 squared is 4. 4 times 2 is 8. So 4 minus 8 is negative 4. Is 4 greater than or equal to negative 4?
No, it's not.
I wish the video could see my face right now. Okay. Yes, that's true. Okay. I was frightened for a minute when I was told it wasn't.
You know better than that.
So it's true. So remember, when it's true, we shade inside. Doesn't have to be fancy. It doesn't have to be fully colored in. I'm not watching for you to stay within the lines, all that other stuff. Just, you know, so I can tell that it's inside. So again, anytime I see x, an x term, intercepts is typically going to be the best way to go. Same thing here. I'm going to take out my x. Then x times x is x squared. X times 3 is 3x. And again, I'm just going to take each part of this and set them equal to 0 to get my 2 intercepts. Those are going to be 2 of my 3 points on the graph. Now here's the one that's not quite so fun. I'm taking each portion of this that has an x and setting them equal to 0, because that's how I can find my zeros or my intercepts.
So why is x minus 3 equals 0?
No, x, because, oh, because I was a bonehead. That's what you had to, okay. Yeah, this is negative 3, thank you. I got a little too ahead of myself.
So all you do is
So now, hopefully later under the wonderful world of editing, you will never see this occur as the whiteout comes out, because I should be using a pencil.
Yeah.
Negative 3. So I have one. I'm just being bad. Now, here's the issue, though, because some of you, if you do it visually, you're like, well, wait a minute. If I start counting into the middle, it's like not on a line. That can happen. Because my vertex here, if I add up 0 and 3 and divide by 2, I get a decimal. That's okay. That's what we have a calculator for. So my x value of my vertex is 1.5 u. My y value, I'm going to plug it in. And again, this is why we like the calculator in this case, because, well, it's going to make this bearable. Did I just do it again?
Yeah.
We're going to watch video stuff and they're never going to forgive me for this stuff.
Yeah, pencils should be much better.
Yeah, I will be penciling from here on out. It's 0 and negative 3, which makes this negative 1.5. Oh, Harty. Harty, Harty, Harty. Okay, pencil in hand now. So this would be 2.25. And that's negative 4.5. Okay, I'm feeling better now. Negative 2.25 will be my y value. So my vertex is this funky number. Yee.
So we know that negative 1.5 would be half. Would just be half of 1.
Correct. Would be right. Halfway in between 0 and negative 3. Yep.
And the same with negative 2, where it would just be like in a quarter way of it, but not actually in half.
Exactly. And it's a solid line because I've got the or equal to underneath. So now I'm ready to do my test point. So anybody? Test point?
Test.
Negative 2 who?
4.
Okay. Negative 2, 4. Definitely not anywhere on my parabola. And again, anything as long as it is not on or outside will make this work okay. So here, plug her back in. So my y value is 4. My x value, oops, is negative 2. So 4 is less than or equal to negative 2 squared is 4. 3 times negative 2 is
Negative
negative 6.
And then 4 and 6 would be negative 2.
So is 4 less than or equal to negative 2? No. False is outside.
True is in.
And true is in. Yes. Besides the fact that some of you are going to tell me this takes too long, are there any other issues with it?
But if there would be ways to simplify it, if there actually was a way to simplify it, it would not work, because if you were not to follow on there, you would get confused and be taking like steps like backwards.
That's right. Sometimes trying to go too fast makes it actually take longer, because then you got to go back and fix stuff. It's true.
Like the perfect example of what you did up on there. It'll be forever marked in there.
It will. So here, we're going to continue to factor. We continue to have an x value. They're like, oh, now it's like diamonds and stuff. Yes, but for some of you, that's going to make this go faster. So I need two numbers that multiply to positive 5 and add to negative 6. Okay, negative 5 times negative 1 is 5, and negative 1 plus negative 5 is negative 6. I'm with you. So what I do again with these, if I'm looking for intercepts or zeros, is I set each part that has an x equal to 0, and then I solve those. Now again, you have to do the opposite to move it to the other side. You can't just, oh, what's this? No, I'd have to add 1 to each side to make that positive, add the 5 to this side, which makes that positive. There's my two intercepts. And again, that's going to come in handy because there's going to be one more step we add in this one. So now to find my vertex, let's see, can I count in this time? Yes, okay. So for my vertex, I counted and found out my x value was 3. Or I could do 5 plus 1 and divide it by 2. Either one will work. And I'll just plug it in here. So my y is going to be 3 squared minus 6 times 3 plus 5. Okay.
So 3 squared would be 9. Negative 6 multiplied by 3 would be negative 18.
That'd be negative 9. Then plus 5, I believe, would be negative 4.
Negative? Wait, what?
9 minus 18. Yep, it'd be negative 9 plus 5 would be negative 4. 3, negative 4. So let's see. What type of line is going through there?
Open.
Dotted.
Dotted. I'm thinking, I'm thinking like, where's it going now?
So we're dotted there. All right, we need us a test point. Suggestions? 3, 3. That's a good way to do this because I don't have to worry about what I'm plugging in. Now you're looking at that, you're going, well, wait a minute. If I'm testing 3, 3, there's nowhere to plug a y value in. You're like, how's this work? I'm only plugging in for x now. Since there's no y, I only plug in for x.
Same thing, if there's no x there, you just plug in for y.
Whatever's there. So I've got 3 squared minus 6 times 3 plus 5 is less than 0. I'll still use the less than 0 part because I need something to compare to. So let's see, 9 minus 18 would be negative 9.
Oh, so
plus
that's
5
like,
is negative 4.
Like, wait.
Is negative 4 less than 0?
Yes.
Yes, that is true.
So on the inside.
On the inside. Now here's where the additional part comes in. There's a way for us to write our solution in interval notation. Like, all the infinity stuff is back. Yes, it is. When we color inside, we're just going to use the intercepts as our values. In other words, we're looking for which intercepts is my solution between. Well, I know they are here. So in this case, my interval notation is just going to be between the x-intercepts. So here's how that works. My leftmost intercept's at 1. My rightmost intercept's at 5. And I use the parentheses because it's the dotted. It's just the, it's not the or equal to. And that's it. So anytime we shade in the middle, my interval notation's just going to be those intercepts. And that's why we do the intercept part of this. The other portion of this, and this is going to be the last one we do. I'm going to save the line value algebraic one for tomorrow because I don't want to go into overload here. We're going to factor this guy out. So if you're like, oh, grown, we have to do slide and divide. Not exactly on this one. Because if we think about it for a minute, the only numbers that multiply to 2 are 2 and 1. The only numbers that multiply, now using my pencil, that multiply to 3 are 3 and 1. So here's what I have to figure out. I got to figure out where the 3 goes and where the 1 goes. Well, if I want to get to 5, let's see. Let's play here. If I did 3 and 1, and I did minus and plus, I'd have 2 minus 3. Yeah,
no,
it doesn't work.
That'll be -1.
Okay,
so
that doesn't work.
So do it the other way around.
Let's try 3 and 1. Which one's negative?
3.
All right, let's try that out. -6 plus 1. Yes, -6 plus 1 is -5. All right. Now again, if you wanted to slide and divide that, you could. You'll get to the same answer. So I'm going to take each of those. I'm going to set my factors equal to 0. And I'm going to solve each of these. And they're going to give me my x-intercepts. So I'll minus the 1 and divide by 2. Ooh, fractional intercepts, lovely. Add the 3 over. So I'm at 3, and I'm at -1/2. And I'll guarantee you're not going to get a whole number vertex out of this. So I'm not going to even attempt to count. I am going to go to my little formula here. So my vertex, add those two guys up. -1/2 plus 3 divided by 2. So let's see, 2.5 divided by 2. 1.25. Awesome. So then to get my y, you got it. Stick it in there. And this is why we like the calculator. Y is going to be 2 times 1.25 squared minus 5 times 1.25 minus 3. Okay, I'm going to the calculator on this one myself. Get out of here. Make sure I type this in carefully so I don't do anything Let's talk about being boneheaded already. Okay. Squared minus 5. And again, I can do this in a regular calculator. I just happen to have this one up. Even better. Now, did I type everything in right? Let's make sure. Yes. 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 Okay. Wanted to make sure. So negative 6.125. So my vertex, one of the prettier ones we've seen, 1.25, negative 6.125. Okay, a little past 1 and a little below 6. And a pen that doesn't work. Maybe it's telling me something. Solid. All All right, let's find us a test point, and we will be ready for our interval notation here. Test point, anybody? 1, 2. Okay.
Wait, so for the test number, can it be like any number?
Any number inside the parabola.
Oh.
Pick any one you want.
So it doesn't matter which one you pick.
Nope, you'll get the same result with any of them. So here,
That should be something like.
so 2 times, let's see here. So we've got 2 times 1 squared minus 5 times 1 minus 3. And that's got to be greater than or equal to 0. Let's see if it is. 1 squared would be 1, so this would be 2. So 2 minus 5 is negative 3. Minus 3 is negative 6 is greater than or equal to 0. I don't think so. So false means we're shading outside. And here's what that means to us on interval notation. Instead of my answers being between the 2 vertices, well, between my 2 intercepts, excuse me, it's going to be everything else. So my answers start way out here at negative infinity. And here they come, here they come, here they come. Oops, it quits being colored in here at negative 1/2 bracket because it's solid. So there's no answers, no answers. Oop, the answers start up here at 3. And off answers go forever. So at this point, because I know there's a couple of things down there at the bottom we didn't get to yet, and I want to see what that's going to affect us. Let's see here. Actually, that's not going to affect us very much because the only two you're not going to be capable of doing at this point are the very last 2. But this assignment as a whole, when we get to it, will be in homework check number 9. This will be assignment number 2. Okay? And even at the very least, I'm going to say this again. I'm going to keep saying this every single time with these until it gets through. Before your head hits the pillow tonight, at least have graphed and shaded a couple of these, because otherwise you are going to forget. So, give a few of these a shot, work them through, find those vertices, and you should be good.